So hello everyone. Today I am going to explain the code for task M3T3D, which was based on traffic control simulator. So first of all, beginning from including and namespaces, the code includes various several standard libraries: IOStream, SStream, Vector, Algorithm, SStream, TimeEdge, Standard Library.h, IOMNM, MPI for parallel computing, and pthreads for multithreading. Then, as we go down, we see that global variables are declared here. So basically, these are the global variables that are being used throughout the program. Prod, prod underscore th, cons underscore th, q underscore size are the control parameters for the number of producers and consumer threads and the queue size. Then you can say comes the structure defined named as traffic signal. It is a structure to hold traffic signal data. Then comes the struct thread arguments. It is a struct to pass thread specific arguments. So signals where signal queues and results are the vectors to store traffic signals in the queue and processed results. Then comes the thread, consumer thread. Basically, these are the vectors to store the thread IDs. Then comes the access log, which is a mutex log for synchronization between threads. Also, MPA signal data signal comes here, which is MPA data type definition for the traffic signal construct. Then here in the code we have MPI helper functions. The main functions are the initializing MPI and the finalizing MPI, get processed count, get processed ID, get processed name, MPI broadcast, MPI send, MPI receive, and at the end finalizing the MPI. So these functions provide basic wrappers around MPI functions to make the communication easier and more readable. Then as we go down in the code, then comes utility functions. From here comes the utility functions. Split string is a function that splits a string based on the delimiter and returns the vector of strings. Generate traffic is the one that generates the random traffic data and saves it to the file. load data, reads the truck data from the file and populates the signal vector. Then comes a Boolean function named compare signals. Here, basically, the comparison function is used for sorting traffic signals objects. Then come producer and consumer voids. Producer void. It produces the thread function in the code, and then comes the consumer void. It gives the consumer thread function to the code. Then we can see thread initialization functions. Basically, these are the void create user, void create consumer, and resolve function. These functions handle the initialization and joining of the producer and consumer. After this come the main function lines of the code, where we can see the get chunk size. It calculates the chunk size based on the number of rows. Then comes the print table row, which prints a row in the table format. Then comes the head, the main function for the master process. Basically, it generates traffic data, sends the chunks of the data to the slave processes, and displays the results. Then comes the slave function. In the slave function, it is the function for the slave processes. It basically receives the data chunks, processes them, and then sends back the results. Then we have made a function of print decorative line. So basically, it prints a decorative line with a specified symbol and length. Then comes the main function. The main function initializes MPI, sets up the MPI data signal data type, determines whether the current process is the master or a slave, or calls either head or slave accordingly. Also, at the end of the execution, it also prints the simulator parameters. Overall, the code is designed to simulate a traffic management system using producer and consumer threads and MPI for parallel processing. The producer threads generate traffic signals which are then consumed and processed by consumer threads. MPI is used for distributing the data and aggregating the results across multiple processes.